In this video, we're going to be solving logarithmic equations. So before I attempt any logarithmic equation question, I like to go to the side of my paper and write a plus, a minus, base, and power. So this right here reminds me that I have to look for an addition rule, a subtraction rule, the base change rule, and the power rule. So that's something for you to keep in mind. Let's dive into the question. This question says log x to the base 2 minus log 5 to the base 2 equals 2 plus log 3 to the base 2. Now the first thing that will kind of throw you off is that this 2 right here is not in logarithmic form. So our first job is to turn this into a logarithmic notation sort of thing. So how do we do that? Now remember we learned a rule that says log a to the base a equals 1. So using this formula, we can say that 3 times log a to the base a equals 3 because log a to the base a equals 1, right? So that's 3 times 1 equals 3. In the same way, we have 4 times log a to the base a equals 4 because if log a to the base a equals 1, then 4 times 1 equals 4. Using that, don't you think we can say log a to the base a times 2 equals 2 because 2 times 1 is equal to 2. So, okay, let's keep that last line in mind and write this out. We're going to have log x to the base 2 minus log 5 to the base 2 equals 2 times log 2 to the base 2 plus log 3 to the base 2. Now, the same thing, you're going to look for the 4 rules. Now, obviously we can use the addition rule and the subtraction rule, but if you notice, we can use the power rule as well with this one in specific, because this 2 is multiplying the log. Therefore, according to the rule, if it's like this, we can turn this 2 into a power of this 2 and write it as log 2 to the base 2 with this. So that's going to be log 2 squared to the base 2. And since 2 squared is equal to 4, we're going to have another equation like this. Log x to the base 2 minus log 5 to the base 2 equals log 4 to the base 2 plus log 3 to the base 2. Now comes the simplification part. Since there's an x in the first logarithmic section, we're going to separate all of these terms. We're going to keep the x on one side and we're going to take the others to the other. So to do that, I'm going to plus log 5 to the base 2 on both sides, and we're going to get log x to the base 2 equals log 4 to the base 2 plus log 3 to the base 2 plus log 5 to the base 2. Moving on, we have all additions on the right hand side. Now if you look to your rules, you notice that we can use our addition rule. That means that all of the numbers in these logarithms are going to get multiplied to give us a different kind of logarithmic notation, pardon me. So that's going to look something like this. Log x to the base 2 is going to equal log with the base 2 4 times 3 times 5. Simplifying 4 times 3 times 5 gives us 60. So log x to the base 2 is now going to be equal to log 60 to the base 2. And the way we can cancel log and the base 2 is if we mention taking antilog. If you just cut log to log and the base 2 like this, if you do that, they're just going to laugh at you. So just say taking antilog and you'll be safe. And once you take antilog, you're going to get x equals 60. That is your answer, and that's how you do these types of questions. Not that bad, huh? Okay, so let's move on to the second question. Remember, I'm going to have my plus minus base and power written on the side to remind me of the rules, and let's dive into the question. So the question says 2 ln x equals ln 25 plus 6, and x should be written in the notation a times e to the base b. Sorry, to the power b. Now, notice how this 6 is not written in logarithmic form or natural logarithmic form, ln form. So let's convert that first. Using the same rule that we used before, we know that when the number and the base are the same, it's going to give us 1. Now, since ln has a base e, the number should be e as well to give us 1. So that means 6 times ln e to the base e equals 6, because ln e to the base e equals 1. Therefore, let's rewrite our equation like this. 2 ln x equals ln 25 plus 6 ln e. I'm not going to write the base e because the base e is kind of assumed since it's natural logarithms. Now, notice how we can use the power rule over here. So using that power rule would give us something like this. 6 ln e could be written as ln e to the power 6, since you can take this over here as a power. Now, let's rewrite our equation again. We have 2 ln x equals ln 25 plus ln e to the power 6. Now, we should use the power rule again actually, because we need to have this 2 over here, because we can't divide by 2 and get rid of this 2, because 25 is not going to be divided by 2 and ln e to the power 6 isn't going to be divided by 2 as well. So let's get rid of this right here and write it as ln x to the power 2. Now, since that's sorted, let's apply the addition rule to the right hand side because we see a plus. So ln x squared equals ln 25 times e to the power 6. Now, since we can cancel out the logarithms or the natural logarithms, let's write taking antilog. Remember, if you don't write this, they'll laugh at you, so write this always. And after that, we're going to get this. X squared equals 25 e to the power 6. Now, to get rid of the square, we're going to root both sides, and that's going to give us x equals 5 times e to the power 3. And that's how you write x in this notation. And that's the question. Simple as that. Okay, so I started off with the easy questions, but now let's step it up a notch and move on to the big boy questions. Now, again, I have my plus, minus, base and power on this side to keep my mind on those things. And let's read the question. So b is equal to log 81 to the base 80 times log 80 to the base 79 times log 79 to the base 78, and so on and so forth. It goes on until log 4 to the base 3. Now, you're going to have to ask yourself one question before you dive into this question. Are the bases the same? No. What do you do then? Base change rule. So now, you're going to remember your rule and you're going to change all of the logarithmic notations into a common base. Let's choose 10, the base 10. So with that, b is going to be equal to log 81 over log 80. I'm not going to mention the base 10 because the base 10 doesn't have to be written. That's the default form. And I'm just using the base change formula. That's all. So the second one's going to be log 80 divided by log 79. The third one's going to be log 79 divided by log 78. And it's going to go on and on until log 4 divided by log 3. That's it. Now notice that the denominators of the previous base change and the following base change sort of cancel out, don't they? So the log 80 in this one is going to cancel out with the log 80 in this one. The log 79 is going to be cancelled out with the log 79 in this one. So following that pattern, the log 78 is going to cancel out with the log 78 somewhere here, and you're going to move on and on and on and on, and you're going to find a log 4 in the denominator, and that denominator is going to get cancelled out with log 4 over here. So after all that cancelling out happens, you're going to get b equals log 81 over log 3, because all of these get cancelled out. Now 81's a big number, right? So we'll have to simplify it. But to simplify it, let's find it with a number that's to the power of 3. So we know that 3 to the power 3 is 9, 9 to the power 3 is 27, and 27 to the power 3 is 81. So since 3 to the power 4 is equal to 81, let's write this like this. b equals log 3 to the power 4 divided by log 3. Now, this is just basic math. Don't overthink it. The logs are going to get cancelled out. b equals 3 to the power 4 divided by 3. So 3 to the power 4 divided by 3 is... No. You have to think it through, because now you can use the power rule. Now since 4 is a power, we're going to take 4 over here. So that's going to be 4 log 3 divided by log 3. Now you can cancel out 3 and 3, giving us b equals 4. That's it. See, I screwed up not thinking it through. Don't do that. Remember to think it through and use your rules. That's it. Okay, so moving on to our final question, and I know this looks tricky, but it gets simpler, so bear with me. Before we dive in, remember I have all my rules noted down on the side, and let's read it out. 4 log root x to the base 5 minus 1 by log 5 to the base 3 equals 3 log 3x squared to the base 5. You're noticing a lot of rules, I know, but one rule at a time. Notice how all of them do not have the same base. We have one base 3. So since it's easier to convert one base into another base than converting 2 base 5s into one base, let's just convert log 5 base 3 into a base 5. So since we all know what it is from the last video, it's going to look like this. Log 5 base 5 over log 5 base 3. Let's write that down. In our next equation, it's going to look like this. 1 by log 5 base 5 over log 3 base 5 equals 3 log 5 log base 5, and we've got a 3x squared. Now, since there are 2 denominators over here in this fraction, this one right here, we can take the lowest denominator into the numerator. And we also know that log 5 to the base 5 is equal to 1 because the base and the number are the same. So if that's equal to 1, then that means it's basically nothing. So we're going to get a different equation like this. 4 log root x to the base 5 minus log 3 to the base 5 equals 3 log base 5 and 3x squared. We're not writing log 5 to the base 5 here because log 5 to the base 5 is just equal to 1, and there's no point putting 1 as a denominator because it doesn't do anything different for us. So I'm going to get rid of that. Now we're going to move these powers using our power rule. So that's going to give us log. Let's write root x as x to the power half. So x to the power half to the power 4 to the base 5 minus, I'm going to leave log 3 to the base 5 as it is, and for this one as well, in the right hand side, I'm going to take 3 onto the power, so that's going to give us log 3x squared to the power 3 to the base 5. Now I'm just going to produce those powers to simplify it down just a bit. I'm not going to touch the bases yet because I don't have to. So 4 times half is going to give us x to the power 2, x squared. I'm going to leave log 3 to the base 5 as it is for now. And this 3 is going to get reduced to the power of 3 for 3 and 3 times 2 for the x. So that's log, log, I'm going to write the base, and 3 times 3 is 9, 3 to the power 3 is, 3 to the power 3 is 27, and x squared to the power 3 is x to the power 6. Now, since we have a minus, remember we can use the division rule. So let's take this, log 5 out, x squared divided by 3 equals log 27 x to the power 6 to the base 5. Remember I said how if you just cut the logs and the bases, they'll laugh at us. So remember, you've got to write take antilog. Sorted. Now you can cut these out, or as a matter of fact, don't do that. Just say take antilog and write your equation as follows. Now it's just a matter of simplifying. Now to get this x over here and this 3 over here, you're going to multiply and divide. So this is going to get multiplied by 3, this is going to get divided by x to the power 6. Now you have x squared, and that's going to be divided by x to the power 6, and 27 is going to be multiplied by 3. Now this is our last stretch of the equation. Hang on with me. Now we're going to write this as, since x squared divided by x to the power 6 is just x to the power minus 4 equals 27 times 3 is 81, and x to the power minus 4 can be written as x to the power 4 divides 1, so 1 by x to the power 4 equals 81. Let's just switch 81 and x to the power 4, multiply and divide. So 1 by 81 equals x to the power 4, and now for the last step we're gonna root this by the 4th root, and that's gonna give us 1 by 3 equals x. With that, I'm gonna end the video solving all of these equations for you to learn and get an idea. Use your resources, use your textbook, and practice these equations for Christ's sake. And I'll see you in the next one. Bye-bye.